Anyway, so vertical line test, remember if you cut the graph one time only, it will be a function. So go through these ones. So do this one, B, and C and D. I might make it a bit smaller. So if you haven't printed this book or you're not using a tablet, you'll need to copy these down somewhere. So do these four. I'll give you a couple of minutes. Think about which one's a function or not function. All right, and I'll ask you in a minute. So we'll do that one first, and then we'll move on to different kinds of relations, which is related to this. All right, I don't think I need to wait very long. How about question A? Is it a function or not? Anyone? What about this one? Is this graph a function? How many times did I cut it? Yipa, got me an answer? Or Nicole?
No, I'm not ask you like how to do it again.
You forgot.
Don't understand.
If you
Yeah.
cut the graph once, ONCE, once only, that will be a function. So in question A, how many times do you cut this graph?
One.
Yeah, one. So that makes it a function, right? I should have reviewed that anyway. So that, yeah, that's a function then. So because you're only cutting the graph one at a time, and it doesn't matter where you cut it, you'll only be cutting it once, won't you? So it doesn't matter how many times you check, you only cut the graph once. So this will be a function by definition. So each X value only has one Y value. So for example, let's make that a bit bigger. With the view. So let's look a bit closer. So for example, so let's clear this out. The eraser. So let's rub that out. So for example, each X value can only have one Y value. So if you come from this number 1 and you go up, there's only going to be one Y value, isn't there? That will be this number here. It could be 6, for example. All right. That 1 can only have 6 as the Y value. There's no other Y values. So if you're making your relation diagram, 1 will go to 6. It doesn't go to any other number, okay, because it doesn't cut anywhere else on the graph. So that's what makes it a function. So 1 only to 6. And then if you had 2, it may come up to 3, depending on what this equation is. I don't know what it is. But so then 2 will only go to 3 here, where this is X and Y. So that's your set of X value. This is your set of Y values. Okay, what about the next one? Anyone, is this a function or not? Let's cut it. How many times do you cut? 1, 2. So now you cut 2 times. So this makes it not a function, or a non-function if you want. You can still graph it. It's still a relation. Okay, these are all relations. So if we were to make an example, if this was 2, this value could be 4, and this could be -4. So when you do your relation diagram, that value 2 will actually go to 2 values, which is not allowed. Okay, so you can't have your X value going to 2 Y values like that. So that's not a function, that graph. It may have an equation, but I don't know what it is, but it's not a function. Oops, okay, what about this one? So if you cut your graph, again, let's use red. like that. You're only cutting once, aren't you? This is the vertical line test, right? So in each case, you're only cutting the graph one time. So for example, this value could be 1. This could be 2. This could be -1. You'll have the same y value. That's no problem because each x value only has one y value, but they can have the same y value. So if that's 1 and -1, this here is 2, like that. This is okay. You can have this situation for a function because you can see we're only cutting the graph once in each case. This value could be 2. There could be another number down here at 1, something like that, and so on and so on. So this is a function because you're only cutting the graph one time. That's the main thing. So it's a function. Right? Are you getting it? I hope so. Now in this one, this is actually called a step function, but this is not actually a function. So you'll see this word in especially Tide book and some other books, step function. You can look them up yourself, but you can see why it's called a step, because it goes up like steps, like this. So if we cut our graph like this, cut through these, it doesn't matter where. Now, the problem is here. Do you see this one here? Here. Because this x value, whatever it is, let's call it 4, actually has 2 y values. See the colored circle, which means it has the same value. So 4, that could be 6 and 8, for example, or 6 and 7. So this is not allowed, this one here. This one's no problem because, for example, if that's 3, this will have value 6, but not 5 because it's an open circle in this case. So if you are doing the diagram here, you can copy it if you like or watch the video later. So for example, 3 will have value 6. That's okay. But the problem here is the 4. 4 has 2 values, 6 and 7. This is not allowed. Whoops. Let's go up to, don't write 6 again. Just write 6 once. So 4 could go to 6, but 4 also goes to 7 here. This is your problem here, this bit. So this shows you that this x value has 2 y values, and that's not allowed. Okay, so this is not a function, non-function. Is that okay? Any questions? All right with that? So that's if you have the graph. But let's go down to the next section, which talks a bit about the relation diagrams. These are your arrow diagrams. I called them relation diagrams before. Let's make that smaller here. So yesterday we called them arrow diagrams, but they're the same thing. So also arrow. Right? Okay, now in some cases, let's look, there's actually 4 cases. This is the first one. Let's look at the first one. So this is where each x value only goes to one y value. And we call that a mapping. These are called one-to-one mappings. This is a new word. It's just a name we use for the relations. So this is a mapping. 0 is mapped onto 5 like that. So you can look that word up a bit more. I'll explain it more later. But this is one number to one number. 1 to 1. 1 to 1. So each x value has only one y value. And we can write that as the ordered pairs. So 0, 5, 3, 3, 6, 1. So this is your ordered pairs here. So this here is a function. okay, because each X value only has one Y value. So that's the first kind you're going to come across. Something like a linear graph would have this. So for example, if it was Y equals X, we would have 1, 1. We'd have 2, 2, 3, 3, like that. So we would have 1, 2, 3 for X. And for Y, we have 1, 2, 3. And you can put more numbers in like that. So linear graphs will be 1 to 1. So an example, linear. They're 1 to 1 graphs like that. Okay, so that's the first kind you're going to see. You can take some notes if you want, but linear, okay, that's an example for 1 to 1. Now this one is 1 to many. So 1 to many, oh, sorry, many to 1. That's the next one. So many numbers, how do we get that? Many numbers, many means more than one. So many numbers to one number. You only need one like that in your graph, and we call it many to one. This one is 1 to 1, but we ignore that. We look at if we ever have more than one going to one value, then we call it many to one. Many just means greater than one element. Here we have 2. So 2 numbers going to one Y value, 2 X value going to one Y value. And so this is still a function. Okay, these are your ordered pairs. So 2, 4, minus 2, 4, and 0, 0. An example of that would be your quadratics. So let's look at the picture and see how that's working. Normally, I would explain this really quickly in class, but online I can show you a bit slower. So an example would be your quadratic, like that. So we've got many to one. So as an example, this could be 2 and minus 2, and that will go to 4 if this is the graph y equals x squared. So 2 squared is 4, minus 2 squared is also 4. So this is many numbers to one number. With your x diagram, we would have 2 and minus 2. And in y, it only goes to 4, like that. So this is many to one. Okay. And we can see it's still a function because when you draw your vertical lines, we still only cut it once, don't we? So it's still a function. All right, it's a function. But we call it many to one. That's your name there. So it's a little bit different than linear. And that's an important distinction for later on. The many to one and 1 to 1, we need that later. Okay, another one could be a 1 to many. So for example, one number, which is the 4, to many numbers. So 1 to many being more than 1. Okay, so we have 0, 0, 4, 2, 4 minus 2 there. If you're graphing that, we would have, okay, 0, 0, let's draw the point. So 0, 0 is here. That's not a problem. We have then 4 to 2. So 4 is here. This is 4 to 2. But then you have 4 to minus 2. So this is minus 2. That's 2. So you can see the 4 value has 2 y values, which is not allowed, like that. And the 4 is in here. So that x value has 2 y values across to there, if you like. So this is not allowed. This is a 1 to many mapping, right? 1 number to many numbers. And this is not a function. An example would be your circle, like that. So if we have a circle, which you'll learn in semester 2, this x value, 1, has 2 y values. Let's call it 2 and minus 2. I'm not sure. Just make it up. So this x value, 1, has 2 y values, and this is not allowed. This is not a function. And you can see your vertical lines cut twice, except on the edge, it will cut once. But most times it will cut twice. So this is not a function here. And we talked about that yesterday. It's not a function. All right, that's the third one. The other one is a combination of, it combines many to one and one to many mappings. We call it many to many. So let's see how that works. So you've got here, you've got many to one, 2 values to 1 value. That's a many to one. But then you have a 1 to many. So it's a combination of both. All right, so that's called many to many. Okay, and that's quite a useless thing, actually. We're interested in the actual functions generally. And when you write them in your ordered pairs, you've got these values here: 0, 0, 4, 0, 4, 2, 4 minus 2, like that. So 4 ordered pairs. And this is not a function. Okay, many to manys are not functions, right? So keep those in your mind, those 4 ideas. Okay, look at this one. Okay, go to exercise 3. I'll help you with the first one. So the first thing you need to do is make your relation diagram. So get your pencil out or your tablet. Now draw your two circles. So call the first one X and the second one Y, because that's what we're used to. And make 2 big ovals like that. And you'll be doing the rest of them in a minute. I'll do the first one. So put your X values. Remember, the first value is always X. The second value is always Y. So you have 1, 2, 3, 4, 5. So put those in X. And then the Y value is 2, 3, 7, 9, 12. If you see the number more than once, you just write it once, okay? And then we match up 1 to 2. So you can use different colored pens if you like. So 1 to 2. And then we have 2 to 3, like this. Then we have 3 to 7, 4 to 9, and 5 to 12, like that. So we can see back at our previous page, that's going to be 1 to 1. That's a 1 to 1 mapping. It looks like this one, doesn't it? So we'll call that a 1 to 1 mapping. Determine if the relations are functions and write down the kind of mapping it is. So this is a 1 to 1 mapping. Or function, if you like. But you'll see this word when we use functions. 1 to 1 mapping, and it is a function. You don't need to draw the graph anyway. Okay, so that's the first one. And how many are there? B, C, D. Okay, B, C, D. So I'll give you 5 minutes to do them, all right? I'll make it smaller. So if you have your, okay, there. I'll make it bigger when I draw the pictures. So I'm going to give you 5 minutes, 5 to 6 minutes to do those, okay? So you need the picture, and the kind of mapping and whether it's a function or not a function. All right, that's your job. I'll put it there. All right. Okay, get to work for 5 minutes and I'll come back in a minute. Okay, you keep working on that. I'll do question B and you keep working. So I'll just write it out. So we have X and Y. Put your numbers in 0, 1, 4, 6. 1, 1, 8, 9. So we only have 1 once. We write it once. 8, 9. Like that. So if you have the number twice, just write it one time. So 0 to 1. 1 to 1. Like that. 4 to 8. And 6 to 9. Like that. So we can see we've got a many to 1 here. You got that? So many numbers to 1. So when you see something like that occur in your diagram, that gives the name. This one was 1 to 1 in every instance, but we found a many to 1 here. So that's many to 1 mapping. Maybe we should spell it better. Mapping. And if you go back up to your diagram, what's the many to 1? Many to 1 is like a quadratic. And so these are functions. So that would represent a function. No need to graph it at this stage. So this is a function, that one. Okay, keep going. I'll do this one. So we make our 2 diagrams again, our circles. And label them. You can label them X, Y. That's what we normally use. So we've got 3, 4, 6. So your X value, 3, 4, 6. So we put them in 3, 4, 6. And we have 5, 6, 9, 12, 15. Like that. And then we match up. So 3 to 5, 4 to 6, 4 to 9, 6 to 12, and 6 to 15. So anyone can tell me what mapping that is? What's the name of that mapping? Anyone? What do we call C? It's not 1 to 1, is it? But you can see you've got 1 to many here. You've got 1 to many, and also this one as well. 1 to many. Many being more than 1. So this is 1 to many. Mapping. And this is not a function. That's the third one from the table. So not a function, non-function. Like that, right? 1 to many. How about the next one? Can't remember myself. So let's have a look. So at least get these in your book or down on paper, because your worksheet you get will be on this section of work and then the next section. So X and Y. So you've got 1, 2, 3, 3, 1, 2, 3. Like that. You've got 4, 4, 5, 8. So 4, 5, 8. There. Then we match up our numbers. 1 to 4. 2 to 4. 3 to 5. And 3 to 8. How about this one? Anyone? What do you see here? You've got many to 1 here. And this one is 1 to many. So you have a many to many relation, okay, a mapping. So this is many to many. It's a combination of the previous two. Mapping. And this is not a function, a non-function. Remember, it's still a relation because these are all relationships between pairs of numbers. But function is a special subset. All right, got that? Any questions? No problem. Okay, so I'm writing fairly slowly so you can copy if you need to copy. Now for your notation, the common notations here, let's have a look at the notations now. The first one is y equals fx. So normally in the past, in like grade 8 and a bit of grade 9, your graph would just be x and y, wouldn't it? That's what we would normally write. And then you would write, for example, the linear could be like y equals 2x plus 1. So that would be a graph like roughly there. And we would just write y, wouldn't we? But now we use this function notation here, fx, for y. So here you could write y equals fx. So this is the thing I was always confused on when I was a student. Like no one ever really explained it, or maybe I wasn't listening that day, but I couldn't get why they were writing thing like this here. But it's just the same thing. Okay, so we're letting this axis be equal to f bracket x. So you're probably wondering why would we do that? So let's write it as fx equals 2x plus 1, like that. Now it's just a convenient notation. That's why we do it. So for example, if x equals 3, what is y? Okay, so if you went to 3 in your graph here, and I wanted to know the value of y, I would just put it in here, wouldn't I? I would write 2 times 3 is 6, plus 1 is 7. But here, you can put the 3 in this bracket, f3, like that. So it's telling me, well, it's asking me what is the value of the function when x is 3. So I put 3 into the function. 2 times 3 plus 1 equals 7. So we would write f3 equals 7, like that. So when x is 3, this is telling me the y value is 7. And you'll see me refer that to like the value of the function. When x equals 3, something like that anyway. But you're going to see this quite a bit later on. Okay, so I've just talked about that already. Now for a quadratic, sometimes you have like real life things you want to talk about. So in this case, instead of calling it fx, You see what was done here? We call it HT, but it's still Y, and this is time. So H represents height, and T is time. But it's still the Y-axis, so we'd write Y equals HT here. So in this question, this is the graph here. HT equals minus T squared plus AT. But don't square the minus sign, it's separate. So for example, this represents your graph, your curve. This is your function. So we would write that as height, like you might hear this written, your height or spoken height with respect to time. Height with respect to time. So that means if you're given a time value, we can calculate the height. So this is time. So this is like a ball thrown up in the air and comes straight down like that. So this is not actually the ball going like this. The ball is actually going in the air and coming straight down in a vertical line. That's your projectile motion that you learned about in physics, which you may have not yet. In grade 10, you will. Actually, you are in grade 10. You might have seen this already. So, but they use different formulas in physics than what we use. Anyway, so for example, here your X value is 1. The Y value is 7, or the height. So as an example, we would go H1, the X value goes in here. So what I'm asking myself is, what is the height when the time is 1 second? So then I'll put it in minus 1 squared plus 8 times 1, like that. So 1 squared is 1, minus 1 plus 8 is 7. So that's your Y value here. So don't get too confused with this terminology. It's just representing the Y-axis. Okay, and we're just using different notation. Okay, I've talked about that already. The other notation you will see is here. In British books, you'll see this a lot. And it's actually the same thing. So they've got F, (X) and an arrow with a head on it. So F, X, like that, and minus T squared plus AT. But it's the same thing. So I don't actually like that, and I usually forget it. So I usually just write it like this. It's the same thing. So these are equal. So if you don't like this notation or you tend to forget how to write it, I will always write it like this. In your test, I don't care how you write it. Okay. So as an example, Fx is 2 on X is the same as F:(X) arrow 2 on X. It means the same thing. Okay. So what's the time? 11 o'clock. So we'll keep going on. So for example, many of the questions will ask you to evaluate a function. Evaluate, find the value of. So in this case, evaluate Fx is X plus 6 when X is 3. So you simply put your 3 into the bracket here. And that's telling you to put 3 into the function here. So 3 plus 6 is 9. So the value of your function when X is 3 is 9, right? Pretty easy that actually. Another one. So it's quicker for me to show you than you to copy all these. So I left them all into the workbook. So you don't have to write any of this down. So this is telling you to put -2 into your function. So -2 will go here and here. I'll make that bigger. Like that. Yeah, so basically you put your -2 value here into your function here. There. That's all you do. Put it in and you'll get the value -1 when you do that. This is a rational function, which you will learn. I'm going to try and teach you quite soon. Rational function. Graphing, yeah, you can graph these, but it's not so simple. But I'll try to teach you if we have time. Okay, the image. Here's a new word for you, image. What is the image of when x equals -2? The image is the y value. It's your output. So this is your y value that comes out. So it's the same thing. So if you want to do this, you put your -2, which is your x value, and then just put it into your function like that, as we just did earlier. So put them in here. And when you do that, you'll get -14, and that's your image. So we could write that as f -2 equals -14. That number is the image. And this is actually called the argument, A-R-G-U-M-E-N-T, G-U-E, argument. That's the x value. I think I might have mentioned that earlier in the workbook. Okay, so image is just your output. And that's another thing we can note. This is called the input value because it's what you're putting into the function. And this is called your output. It's the thing that you get after you put your x value in. That's called the output. Input, output, in, out. Fairly straightforward. So here's another example. And you'll be doing these. We got to do some more sets, so we might do that on the next lesson. Just trying to finish this. When do we finish? 10? When do we 10, 20, 11, 20, 11, 10. So we only have about 5 minutes left. So we have to finish soon. Okay, so if your function is equal to 10 and fx equals 2x minus 9, find the value of x. So in this case, let's just write it again, fx equals 10. But here we're also saying that it equals 2x minus 9. So we can write 2x minus 9 here, can't we? Because they're both equal to fx. This is actually your y value, 10. So this bit we can just cut off. So let's rub that off. It's all here anyway. And then that is 19 equals 2x. So x is 19 on 2, which is 9.5 there. All right, with that one. For what value of x does the function not exist? Meaning it's undefined. Remember, anything, if you've got a, for this to be undefined, you would be dividing by 0. It doesn't matter what a is. So if it's x plus 3x plus x cubed or whatever, and you divide by 0, this is undefined because you can't divide by 0. If you put it in your calculator, you get error. So whenever you're dividing anything by 0, it will be undefined. So if we look at our function here, that means if our function has 0 down here, if this is equal to 0, this function will be undefined, this word here. So If that equals 0, the function's undefined. I did it down here. So 3x minus 1, if that equals to 0, we just rearrange it. We'll get x is 1/3. So that means your function is undefined. There is no graph at that point. And we learn that a little bit more later. So if you tried to graph this at x equals 1/3, there's no graph. And I can show you quickly maybe what that looks like. So 1/3 is here. So don't worry if you don't understand yet. The graph will look something like this, maybe. So your graph is broken at this x value. And when we start graphing more, we'll see what's going on there a bit more. Okay, so don't worry about it at this time. But that's what it means. So in these ones, we need to substitute these values into the function. So you're going to have to put a minus x in there and a minus x in here for this one. So that would be f minus x is 2 times minus x squared plus 3 times minus x minus 1. So this still has x, this will still have x in it, doesn't matter. So minus x squared is x squared, so 2x squared minus 3x minus 1. That's your answer. That's it. Nothing else to do here. That's the answer there. In this question, you should put this value into your function. So in that case, this, what is ever written here, will go into x here. And you put that into here. So you'll have f, x plus 4. Substitute that into each x value here, wherever you see x. So you'll have 2 x plus 4 squared plus 3 x plus 4 minus 1. And what you should do there is expand and simplify. So expand and simplify, because that's not really finished yet. And you'll get some quadratic like this here. And that is shown here. I did it already. So that would be your answer after you've simplified and expanded all of that there. And that's the previous answer there.